Here are a couple of examples of graphing a trig function. And I called it example number 5 because I counted the ones that we just did, and it seemed like this was the 5th one. Determine the A period, B domain, C range, and D, draw a graph of the function y equals 3 cosine of 2x minus pi plus 1. So you can stop the video and write all this down and then start it back up again if you want to. I'm going to keep going. Okay, so first the period. Okay, so to find the period, coefficient, because remember, we need to find the period coefficient. Now, we've been given this equation, so we have to figure out what the period coefficient is, and then we'll determine what our period is. So to find the period coefficient, we must factor the 2 out, which I'm saying that, but that it really isn't going to help us find the period coefficient too much, but when we do that, we've got that, right? Because when you factor, you're dividing by 2, dividing by 2. And if you wanted to check it, you can distribute back and make sure you get back to what you started. Well, that right there is our period coefficient. When you factor that out, it more helps you with your phase shift. I don't know why I said it would help you with your period coefficient, but I'm just reminding you of all the things that we have based on what we did just a little bit ago. And then we said this was our amplitude. Okay. Well, if the absolute value, our amplitude is the absolute value of that number. Okay. So now, our period is equal to 2 pi divided by the absolute value of whatever this is, this period coefficient is. And so our period is pi. So there's our first step, our part A. And that means our function completes one cycle in pi radians. Okay. Part B. Domain. Sine and cosine functions always have a domain, negative infinity to positive infinity. Okay? There's nothing that will make it division by 0 or give you, something underneath a root for those, unless, you had a weird situation. But if it's a sine or a cosine function, you're going to have domain negative infinity to positive infinity. The next thing we're going to find is the range of the function. So to find the range, you have to look at what numbers it goes to. So it has a vertical shift up 1 unit. It has an amplitude of 3. So we must add 1 plus 3, and that gives us 4. And take 1 minus 3, that gives us -2. So you start with your 1 is always going to be your center line, right? Or not, I mean for this problem, your 1 is your center line because it's shifted up. So that's your center line. It's shifted up 1. That last number is going to always be your center line. And so if we add 3, 1, 2, 3, that gives us 4. Subtract 3, 1, 2, 3, that gives us -2. You can see that this shows you've got your amplitude of 3 here and your amplitude of 3 here. And so the center line is y equals 1 because the whole thing was shifted up 1. So that gives you a range from -2 to 4. So that really does help you when you're figuring out your range, okay? 4 is going to be your highest, your maximum. -2 is going to be your lowest, your minimum. Okay, part D. Now we get to graph it. Okay, so I've already got it kind of set up here. We do have a phase shift. Our phase shift is pi over 2. And so I'm going to put phase shift pi over 2, and that's pi over 2 to the right. And so normally, I'm just going to put a little dash in there for normally. If I just had this function, if it didn't have a phase shift, okay, and it's a cosine function, and it's positive, right? Positive cosine, that means it's going to be at its highest point at 0, okay, for a non-phase shift. We said that it completed a cycle. That means it went down to the lowest, back up to the highest, 1 cycle in pi radians, okay? Now, this point right here, which corresponds to some x value, this point right here corresponds to an x value, and this minimum corresponds to an x value, okay? Notice that there are 1, 2, 3, 4 parts to that. If you take your period and divide it by 4, it tells you what to break your graph up into. So what I mean by that is if I take my period divided by 4, then it tells me, oh, well, these are going to be my my stops for my, all of my little, I'm at the highest at 0, then it goes down to pi over 4, or it goes down to 0 at pi over 4, then it goes to the lowest at pi over 2, and then back up to 0 at 3 pi over 4, and then back up to the highest at pi, because it's completing a cycle in pi radians. Now, this is if we didn't have a phase shift. So what's going to end up happening is everything's going to get shifted. So we're going to go ahead and draw our axis. And since it's shifted pi over 2, we've got, well, let's just kind of guess. Pi 2 pi, right? And we said we were breaking this up into fourths. Okay, and so this was pi over 4, pi over 2, 3 pi over 4, that's 4 pi over 4, 5 pi over 4, 6 pi over 4 is 3 pi over 2, 7 pi over 4, 8 pi over 4 is 2 pi. So we are going from 1, 2, 3, 4 to -2 with our center line at 1. Oops. And so instead of it being at its highest point at 0, it's going to be at its highest point at pi over 2. Okay, and then every 1/4, it's going to hit something. So after a fourth, it's going to be at 0. Then after another fourth, it's going to be at its lowest. Another fourth, 0. And then, oops, sorry. I accidentally put it there instead of, so don't put one there. Oops. Let's put that back. And then finally, highest point again, another fourth later. So and you could keep going if you wanted to. I just wanted to show you at least one cycle. So that is what your function, and you know, if this is at pi over 2, that means you're back to 0 at pi over 4. And then you're back to the lowest at negative, or at 0. But, so you could keep going. It's however you want to do it, whatever, you know, is making you feel better. If you want to keep going, but if you break this up into each one of those pi over 4s, you can easily draw it because you've got it, you know. And so what you're going to do is you take your period and you divide it by 4. Always, because that's going to like break it up into the different divisions that are naturally there for every single one of those sinusoids. See how they're broken up into 1, 2, 3, 4 parts. Okay, so this works pretty good when you're sketching them. All right, I got one more example and then I'll be done. So my next example is example number 6. Determine the A period, B domain, C range, and D draw the graph of the function y equals 2 sine of 4x plus pi plus 3. Okay, again, you can stop right now and you know, take a break to write this down, or you can keep going. So I'm just, you know, I don't know my phase shift yet. You know, that's not going to be my phase shift, but that everything else is going to be the same. There's my vertical translation. So I've got my amplitude is 2. I've got my period coefficient is 4. I've got my vertical translation, which is also your y equals that is your center line, right? And if I wanted to find out what my phase shift is, I'm going to write this as factoring out that 4, so that leaves me with x plus pi over 4. And so that negative pi over 4 is going to be my phase shift. That means, you know, it's going to start, it goes positively through the x-axis at negative pi over 4. So if we finish this up, phase shift, negative pi over 4. Okay, so part A. first thing I did was find my period. Okay, I know my period coefficient. So period equals 2 pi divided by the absolute value. My period coefficient is 4. So that means pi over 2 is my period. That means it completes a cycle in pi over 2 radians. And if I wanted to break this up, I would break it up into fourths or multiply by 1/4. That means every pi over 8, it's going to go to a different thing, you know. So, if it starts at its highest, then it would go to a 0, then in pi over 8, then another pi over 8 would go to lowest, and another pi over 8, 0, and another pi over 8, highest again. So that is why we multiply by 1/4 or divide by 4. This is actually the period, but we are finding the places on the graph where we can make sure that we have the highest and the lowest and all that stuff. Okay. Part B, the domain we said was negative infinity to positive infinity for all of the sine and cosine functions. The range, now I said my center line was 3, okay? So if I'm thinking about a graph of this, and 1, 2, 3 is my center line. And my amplitude is 2. That means I'm going to 4, 5, and I'm going down 3, 2, 1. So from 1 to 5. So this range is going to be from 1 to 5. Notice that this gives me an amplitude of 2 and an amplitude of 2. Highest point 5, lowest point 1. I see that it's a positive sine function, okay? Positive sine. That means I know, oops, I wrote sine the other way. I know that it goes positively through 0, 0, right? Whenever we're graphing a sine function, that's, normally it goes positively through 0, 0. This time, if I just did like a regular sine function, like one cycle of it without a phase shift would look like that. Okay, goes from 1 to 5, and one cycle of it we said was pi over 2. This is without a phase shift. And you could, continue on in the negative direction and do the same thing, for another cycle. So, and that would give you negative pi over 2 here. But we don't have that. That's why it's in dashes. So what we do have is it's going to go, this point right here is going to get shifted 1 pi over 4 to the left. And pi over 4 is halfway here, right? So halfway between, if I multiplied negative pi over 2 by 1/2, I get negative pi over 4. So it's halfway. So therefore, this is where I want my 0 to be. And then I want it to, go up. And we also have to remember what it's doing. Like this is your pi over 4 here. But remember, it was hitting its highest, pi over 8. So this is 2 pi over 4. Here's 3 pi over 8. This is 2 pi over 8. 3 pi over 8. This is 4 pi over 8. So it was doing, its highest, back to 0, its lowest, and then back to 0. Those were its 4 divisions, right? And it was every pi over 8. It was doing that because that gave us that completing a cycle in pi over 2 radians. And remember, we multiplied that by 1/4 so we could get pi over 8. Okay, so since this graph is getting a little crazy, I'm just going to draw a new one for our new function, okay? So we know it's going from 1, 2, 3, 4, 5 to 5. That 3 is our center line. And we said that if this was, I'm just going to put it right here, negative pi over 2, then halfway would be negative pi over 4. Halfway there from that would be negative pi over 8, right? And so then we've got positive pi over 8. Then we've got positive pi over 4. I didn't put 1 in between here, but 1, 2, this would be negative 3 pi over 8. So this would be positive 3 pi over 8, and this would be positive 4 pi over 8, which would be positive pi over 2. So we are saying that we are going to start our function at negative pi over, what did we say? It was shifted negative pi over 4. And it's a sine function, and it's going to be going positively through. Pi over 8 units later, it's at its highest. Pi over 8 units later, it's at 0. Pi over 8 units later, it's at its lowest. Pi over 8 units later, it's back to 0. So here we go. We're going to sketch. And this is the sine function shifted to the left pi over 4 units. So instead of, here's the one that was not shifted. Okay, do you see how it's going positively through 0, 0 at 0? And this one is going positively through at negative pi over 4 because that was my phase shift. Okay, so notice that at 0, this one's going negatively through. Do you see how they look different? This one's going positively through at 0, and that one's going negatively through at 0 because I basically just shifted this over. And so this piece right here is at my 0 now. Okay? And so that's just graphing one cycle of that function. And I mean, you could keep going like I did before. Since I'm at 0 here at negative pi over 4, if I go to just pi over 8 later, I'm at my lowest. Pi over 8 later, I'm at my 0. So I could continue like that. Pi over 8, I'm at my highest. Another pi over 8, I'm at my 0. I could go one more, and I could be at my lowest again. So this point right here is going to be this is going to be 5.